my fellow viewers. Welcome to MR.Wanyoike, the digital learning platform. In front of you is MR.Wanyoike, a mathematics teacher. In today's lesson, we are on continuation of probability. In today, we are going to look on combined event where we have which are done without replacement, which are supposed to be done without replacement. And as far as our example, there is an example one here. There is a question that reads, there is this example, there is a bucket containing 2 blue pens and 3 black pens. The pens are identical except for colors. 2 pens are picked from the bucket, each at a time, each at a time without replacement. Find the following probabilities. First pen picked is blue, and the second one, the first 2 pens picked are blue, and Roman 2, at least 1 pen picked is at least 1 blue pen is picked, and Roman 3, at most 1 blue pen is picked. And finally, we have picking 2 pens of different colors. Having said that, what you are supposed to do, you are supposed to come up with a tree diagram. You are supposed to come up with a tree diagram. And as far as a tree diagram is concerned, you are supposed to draw a tree diagram which will help you or guide you, here. I am going to come up with a tree diagram. We have it here, that is blue. There is a black, meaning that the one at the denominator is not blue. And then we have, this is the symbol for black, and this is the symbol for blue. And also I will have blue and not blue, meaning that the other one is black. Here the same, I have a blue, and I have the one which is not blue, meaning that the second one is the one which is black. And here I will be having outcomes, that is blue and blue, and here I have blue and black. Then here I have the first one being black and blue, then I have a black and also another one which is black. Having said that, I'm going to represent all. Alternatively, you can use different colors. This one for black, I use a letter black. I use a different black so that it can appear it is black. Also this one, I can use a different one so that you can see that there will be black and also there will be blue. And as far as this one is concerned, I will be having a black, and here I will be having blue black, and here I'll be having the second one being black, the first one being black, and both of them are supposed to be black. And therefore, I think our question will become very, very easier to tackle this time. And as far as this question is concerned, I want us to practice practically, to do it practically. For instance, I have the pens here. I have 5 of them, and 3 of them, you can see these 3 are black and these 2 are blue. And therefore, if I put them in an empty bucket which does not contain anything, and therefore if I put all of them, it means that when I'm going to pick during the first picking, how many blue pens am I going to get? I'm supposed to get 2. Why? Because I put 2 blue pens. What about as far as black is concerned? I'm supposed to get being represented by 3. There are supposed to be 3 pens in the bucket because I put 3 pens which are black in the bucket. And therefore, the initial probability, I can remove the blue one so that I can write it with it here. The initial probability of a blue during the first picking is supposed to be 2 out of 5 because there are 3 black and 2 blue, and therefore 3 plus 2, you are supposed to get 5. What about the probability of blue? The probability of black, is supposed to be 3 out of 5. That is during the first picking. Those are the probability. And assuming that the one which the pen which I have used to write on the board, I have not replaced it. So I put it on my pocket. I put it on my pocket. And therefore, if I come to the second picking, during the second picking, I want us to confirm. You can see that one of the pen, which is blue, I have placed it on my pocket. And therefore, what is the total number of blues pen as far as the second picking is concerned? They are supposed to be, you can see that as far as the blue pens are concerned, I will get 1. And what is the total number of all pens in the bucket now? It's supposed to be 4. Why are they 4? Because one of the pen was picked during the first picking, and I put it on my pocket, in my pocket. And therefore, it means that if I want, let me return it. If I want to fill this space here, as far as blue is concerned, you can see that this is facing what? This V faces blue, and therefore it means that the number of blue pen which I will get if I had picked a blue one during the first picking, I am supposed to get only 1 out of 4. Why 4? Because one blue was picked and I placed it into my pocket. What about the number of black? We calculated with you and we found they were 3 out of 4. Why? Because there were 3 during the second picking. There were 3 black and 1 blue, and therefore the probability becomes 3 out of 4. What about now the one pen which I had picked, which was blue? Now I return it. I assume I had not picked a blue. I had picked a black. So I will return this one, and once I return, I will maintain the original number of blue, assuming that I had not picked a blue. I picked a black, meaning that I will pick 1 pen and I put it on my pocket. I assume that during the first picking, I had not picked a blue. I picked a black, meaning that when I'm coming to pick for the second time, remember, during the first picking, I assumed that I had picked a black and I did not return it. And therefore, during the second picking, I will not get the original number of pens in the bucket. Why? You can see the results. There is nothing else, but I have 2 black and I have 2 blue. Why? Because during the first picking, I assumed that I had picked the black. And the black one is the one which I have already placed it in my pocket. And therefore, as far as the probability of black is concerned, they are supposed to be how many? You can see there are 2 blacks. Out of how many number of pens? The total number of pens are 4. So it is 2 out of 4. And therefore, I will write it 2 out of 4. I will use this one, the one which I had put in my pocket as the number of black are supposed to be 2 out of 4. What about the number of blue? The number of blue remains the same. That is 2. I assume that during the first picking I had not picked a blue. I picked a black out of 4. So that is how you are supposed to answer that tree diagram. Having said that, then you are supposed to come up with to the first question, and the first question is first pen picked is blue, and therefore I'm going to this is the first picking, these branches, 2 branches, and the other branches are second picking. So as far as the first picking is concerned, I'm supposed to look to concentrate on the first branches. These are 2 branches here, and I'm going to say probability of picking a blue should be given by this value here, which is supposed to be 2 out of 5, because I'm told during the first picking or the first picked ball, picked pen is blue. What about part B of Roman 1? So the first two pens picked are blue, and therefore the first two picked pens are blue. So it means that the first picking and the second picking, blue. So I will take this 2 over 5. I multiply by 1 over 4. And the answer, I will get it as by 2, 1, by 2, 2. So I'll get 1 over 10. So the probability of picking two pens which are blue is supposed to be 1/10 or 1 over 10 as far as picking without replacement is concerned. Having said that, I'm going to come to the question number 2. At least one blue pen is picked. So what is the probability? Roman 2. At least one blue pen is picked. One blue pen is picked. What is the probability of it? And the probability of it, we can have it written by this. At least one, meaning that you may pick one blue or more than one blue, maybe two. Now you will say it is given by probability of 2 blues or the probability of a blue and also a black. The second one, blue and black. And also you get or the probability of, you start with a blue as from the results on the tree diagram. You start with black, then followed by blue. And having written that, I'm going to come up with the values. As far as the probability of blues is concerned, I have already calculated it. That is 1 over 10. And therefore, I will write the first one is 1 over 10, plus the second one should be 2 over 5. You reflect here, 2 over 5. You multiply by 3 over 4. Then you add 2, the third one, 3 over 5. 3 over 5, you reflect here. Then you multiply by here, 2 over 4. 2 over 4. Then you close the bracket. So you'll get 1 over 10 plus by 2, 1, by 2, 2. So you'll get 3 over 10 plus by 2, 1, by 2, 2. This is supposed to be 3 over 10. And what is the answer? You're supposed to get the total answer as 7 over 10. That is the total probability. At least one blue pen is picked. That is the answer. Alternatively, you can say the probability of at least one blue is given by 1 minus the probability of picking all of them being black. All of them being black. And therefore, I will come and write here 1 minus the probability of black here. You can see it is 3 over 5. 3 over 5. You multiply by 2 over 4. So by 2, 1, by 2, 2. So you are supposed to get 1 minus 3 over 10. 3 over 10. And the answer becomes 7 over 10 still. So this is alternative method. So you can either use this one or use this one. You can see that I had 3 possible outcomes as far as method 1 is concerned. And therefore, as far as method 2 is concerned, you just say the total probability is always 1 for all outcomes, and therefore you're supposed to subtract the probability of an outcome which is not expected. And therefore, having written that, I have come to the end of today's lesson. Your presenter was Mr. Wanyoike. You can, for more inquiries, you can search me on YouTube using Mr. Wanyoike. And till next lesson, bye-bye.